Have you ever looked around, really looked, and just for a second wondered, is this real? What if the answer to that mind-bending question is no? What if your entire reality, your very consciousness, is actually part of some grand, incredibly sophisticated computer program?
Yeah, it definitely sounds like something straight out of science fiction, doesn't it?
Yeah.
But today we're taking a deep dive into a really groundbreaking 2003 paper. It's by the philosopher Nick Bostrom, and it's called "Are You Living in a Computer Simulation?"
Right.
And this isn't just, a fun thought experiment. It's actually a rigorous philosophical argument. And it's one that's backed up by estimates from, well, serious technologists and physicists, too.
Okay, so our mission today is to really unpack Bostrom's core argument. We want to understand the fundamental assumptions it's making. And then the really exciting part, explore the truly mind-bending implications if his conclusion turns out to be true, or if the alternatives are true instead. We're basically going to unlock why, according to this paper, at least one of three pretty surprising propositions must be true about our existence.
Okay, so let's start with the foundational idea itself, the simulation hypothesis. At its core, it suggests that future civilizations, ones that achieve just enormous computing power, might decide to run these incredibly detailed ancestor simulations.
Ancestor simulations.
Yeah.
So like simulations of their own past, or maybe variations of it.
Exactly. And they'd be complete with conscious beings living inside them.
Okay, and here's where it gets really interesting for us, right? Because if these simulations are detailed enough, and if this widely accepted idea in philosophy of mind, what was it, substrate independence, if that holds true,
Substrate independence.
then the people living inside those simulations would actually be conscious. They'd experience reality just like you or I do.
Precisely. That's the crucial step. And if simulations like that become widespread, if a posthuman civilization runs loads of them, then the sheer math leads to a pretty startling conclusion. The vast majority of minds, like ours, would belong to simulated individuals, not the original biological ones.
Wow.
Which means that if we're being rational about it, we should probably assume that we're likely among the simulated.
Okay. So to really get our heads around this argument, we need to understand the groundwork Bostrom lays out. He built his case on two crucial pillars you mentioned, the nature of consciousness itself and the staggering potential of future tech. Let's start with that consciousness part, substrate independence. What does that actually mean for our minds, and why is it so vital here?
Right. Well, what's fascinating is that substrate independence is a fairly common assumption in the philosophy of mind. It basically says that mental states, like consciousness, aren't inherently tied to a specific physical thing, like our carbon-based brains.
So consciousness could, in theory, exist on silicon chips.
Yeah.
Or something else entirely.
In principle, yes. As long as the computational structures and processes are implemented correctly, it doesn't even need a super strong version of functionalism, the idea that mental states are just their function. It just needs the ability to replicate the computational processes of a human brain, maybe down to the level of individual synapses even.
So if we could computationally model how a brain works, consciousness could just emerge from that model, no matter what it's running on.
That's the idea.
And even complex stuff like neurotransmitters, their effect on how we feel, that's assumed to just be part of the computation.
Within this framework, yes. Their influence on subjective experience is seen through their direct or indirect computational impact.
Okay.
So that's the leap. It suggests that a sufficiently detailed computer simulation could, in principle, create conscious beings. Now, it's still a philosophical assumption, of course, even if widely accepted in some circles, but it's absolutely foundational to Bostrom's whole argument.
All right, so the brain is basically a super complex computer. Replicate the computation, replicate the consciousness. But that still sounds like it requires an absolutely insane amount of computing power. Are there limits? I mean, what Bostrom imagines future civilizations could achieve.
Yeah.
Is it just limitless?
Well, obviously we can't do anything like this now, but there are persuasive arguments that technological progress, if it keeps going, will overcome these limits, maybe in decades, maybe centuries. We're talking about post-human civilizations potentially converting astronomical resources like whole planets into unbelievably powerful computers.
Wow. So the scale of computing power we're talking about makes today's biggest supercomputers look like, what, pocket calculators?
Pretty much, yeah. I mean, people like Eric Drexler talked about systems the size of a sugar cube doing 10 to the 21 instructions per second.
A sugar cube.
And then you have estimates for planet mass computers reaching something like 10 to the 42 operations per second. Seth Lloyd even calculated an upper bound for a 1 kilogram computer at 5 times 10 to the 50 operations per second. It's just hard to fathom.
Mind-boggling numbers.
Absolutely. And compare that to what it might take to simulate a single human mind. The rough estimates are around 10 to the 14 to 10 to the 17 operations per second for the whole brain.
Still huge, but compared to those planetary computers.
Exactly. And that's probably conservative. We might find efficiency gains using non-biological processors because our brains have a lot of redundancy. Memory isn't really seen as a bigger bottleneck than processing power either.
So what does that mean for ancestor simulations?
It means that for a post-human civilization, running maybe billions of ancestor simulations isn't just possible, it could be computationally, well, trivial.
Trivial.
Like us running a calculator app on a modern supercomputer, the actual cost is almost negligible compared to the total capacity.
Okay, but what about simulating the environment? Everything around us, wouldn't that mean modeling the whole universe down to the quantum level? That sounds impossible.
But it doesn't need to. The key insight is that the simulation only needs to be detailed enough so that the simulated humans, going about their lives, don't notice anything weird.
So stuff far away.
Distant stars, galaxies, they can be highly compressed representations. You don't need to simulate every atom. And microscopic details could be sort of filled in on demand.
On demand. Like only if I pull out an electron microscope and look really closely.
Precisely. If you never bother to look at the quantum foam in your coffee, why bother rendering it? It's about efficiency.
Okay, that makes sense. And the paper mentions the simulator could even, tweak our brains to fix glitches? Or just rewind time a bit to avoid a paradox.
Exactly. So the main computational heavy lifting is actually simulating all those organic brains interacting. Bostrom estimates the entire mental history of humankind might require something like 10 to the 33 to 10 to the 36 operations in total.
Okay.
Which means a single planetary mass computer could simulate all of that using less than 1/millionth of its processing power for just 1 second.
1 second.
So the conclusion is stark. Post-human civilizations could run a huge number of ancestor simulations, even if they only dedicated a tiny, tiny fraction of their resources to it.
Right. And given those absolutely staggering technological possibilities, Bostrom then hits us with his central provocative question, the one leading to the trilemma. He asks basically, if there's a good chance our civilization eventually gets to be post-human and runs lots of these ancestor simulations, then why aren't you living in one?
And from that, he argues that given the immense computing power they could have, at least one of these 3 surprising propositions must be true.
Okay, let's hear them.
Proposition 1, PFS 0. This means the fraction of human-level civilizations that survive to reach a post-human stage is basically 0. We don't make it.
Okay, extinction, essentially.
Proposition 2, it's ES 0. This means the fraction of post-human civilizations that are interested in running ancestor simulations is basically 0. They can, but they don't want to.
Right, disinterest.
And Proposition 3, Thim 1. This means the fraction of all observers with experiences like ours who are living in a simulation is almost 1. We are almost certainly simulated.
Simulation, okay. So extinction, disinterest, or simulation.
Exactly. And the crucial logical point is that these 3 options cover all the bases. They're mutually exclusive and exhaustive. If the first 2 are false, if civilizations do tend to reach post-humanity and they are interested in running simulations, then the third one must be true.
Why must it be true?
Just because of the sheer numbers. The potential number of simulated minds would vastly, astronomically outweigh the number of original biological minds in the basement reality.
Got it. The odds just stack up overwhelmingly in favor of being simulated.
If 1 and 2 are false, yes.
Okay. Now, to help us figure out where we might sit in all this, Bostrom introduces something called the bland indifference principle. What's that about?
Right, the bland indifference principle. It basically says this. If you know that a certain fraction, let's call it X, of all observers with experiences like yours live in simulations, and you have absolutely no other information that could distinguish your specific experience from any other observer's experience.
Like no flashing "you were in a simulation" sign in the sky.
Exactly. No special knowledge. Then your rational belief, your sort of subjective probability or credence that you are in a simulation should simply be X.
Okay, can you make that a bit more concrete?
Sure. Bostrom uses an analogy. Imagine there's some genetic sequence S found in, say, the junk DNA of 10% of the population, and this sequence has absolutely no observable effects. You can't feel it, it doesn't make you look different, nothing.
Right.
Unless you've actually had your DNA sequenced, the rational thing to do is assign a 10% probability to you having sequence S.
Makes sense. You just go with the base rate.
Exactly.
Yeah.
And the same logic applies to being in a simulation. If you know the fraction X, but have no distinguishing information about yourself, your credence should be X.
And Bostrom makes a point of saying this is different from, like, the doomsday argument.
Yeah, he does. He argues this principle is weaker and less controversial. The doomsday argument makes a stronger assumption about being a random sample from all humans who ever live or will live. This bland indifference principle only applies when you genuinely have no information to tell you which group you belong to, simulated or original.
Okay, that clarifies things.
Yeah.
So let's dive into what each of these three outcomes from the trilemma actually means for us. Scenario 1. Proposition 1 is true. PF is basically 0. Humanity doesn't reach the posthuman stage. What does that imply about our future?
Well, if PF is near 0, it means human civilization almost certainly fails to get there. It forces us to confront the idea that advanced civilizations might just be incredibly fragile.
So we hit some kind of wall?
Yeah, an existential wall. It
Yeah.
could mean we go extinct. Maybe we invent some dangerous tech, self-replicating nanobots. The classic gray goo scenario is often mentioned that wipes us out.
Or maybe nuclear war, climate change. Lots of contenders, sadly.
Or it could mean we just stagnate. We stay at roughly our current tech level, maybe a bit higher, for a very long time, and then eventually die out from something else.
So it suggests we aren't special. We're not guaranteed to overcome these hurdles. That's pretty sobering.
It is. It implies there's some great filter, as it's sometimes called, still ahead of us, and most civilizations don't pass it.
Okay, what about scenario 2? Proposition 2 is true. Posthumans could run simulations, but they just don't. The fraction EF is near 0. How likely is that?
Yeah.
We're so curious about our own past.
It's a possibility Bostrom takes seriously. If Ostrom is close to 0, it means nearly all posthuman civilizations choose not to run ancestor simulations. Why might that be? Well, he offers a few conjectures. One is a strong ethical prohibition. Maybe advanced civilizations universally decide it's wrong to create simulations, perhaps because of the suffering the simulated beings might experience.
But that would require, like, universal agreement and enforcement across potentially vast posthuman societies, wouldn't it? Seems like a tall order.
It does seem like a strong requirement, yes. Another possibility is they simply lose the desire. Our human motivations, our curiosity about history, running simulations, maybe that all just seems primitive or, frankly, silly to a post-human intelligence.
So they'd have moved beyond such things. Maybe they prefer, I don't know, direct pleasure uploads or exploring pure mathematics or something.
Perhaps, or maybe the scientific value of ancestor simulations is just negligible to them. They might have far better ways of understanding the past or themselves.
So the implication here is that posthuman societies would be radically different from ours, like maybe lacking individuals with the wealth and freedom and, frankly, the human drive to run such a project?
That seems to be the implication, yes. It requires a pretty profound shift in motivation, ethics, or societal structure compared to what we know.
Okay, and that brings us to the third scenario, the one that gets all the headlines. Proposition 3 is true. We are almost certainly living inside a computer simulation right now. What does that mean for how we understand reality, our universe, everything?
Well, if we are simulated, then the universe we see, the entire cosmos, is just a tiny piece of the total physical reality. It's not the fundamental level.
We're running on hardware somewhere else.
Essentially, yes. And the physics of that base universe, where the computer running us is located, could be completely different from the laws of physics we observe in our simulation.
It could be layers, right? Like Russian dolls.
Exactly. Bostrom talks about this. Simulated civilizations could themselves become post-human, develop the technology, and then run their own ancestor simulations on computers they build within their simulation.
Virtual machines inside virtual machines.
Stacking up, potentially. And he makes a really interesting point. If we ever get to the stage where we create our own ancestor simulations, that would actually be strong evidence against the first two propositions, extinction and disinterest. Because we would have survived and we would be interested.
It means.
It would strongly boost the probability of the third proposition. It would suggest we are simulated and maybe our simulators are simulated and so on up the chain.
That's a wild thought. Is there any counter-argument to that stacking idea?
Well, one potential issue raised is the sheer computational cost. Simulating even one post-human civilization capable of running its own simulations might be incredibly resource-intensive for the level
So
above.
the basement level simulators, the ones at the very bottom of the stack, might just pull the plug before their simulations get that advanced to save resources.
It's a possibility, yeah. Maybe simulations typically get terminated before they reach the post-human stage capable of creating further simulations.
This scenario also brings up these almost theological parallels, doesn't it?
Yeah.
The posthumans running our simulation, they're kind of like gods to us.
In a way, yes. They created our world. They're super intelligent compared to us. They're potentially omnipotent within our simulated physics. They could change the laws if they wanted. And omniscient in that they could monitor everything happening inside.
So if we are in a simulation, what does Bostrom say about the ethics? Does it change how we should act?
This is where it gets really fascinating ethically. Bostrom suggests that if nobody can be truly sure they're at the basement level of reality.
Right, because even the simulators might be simulated.
Exactly. Then everyone, at every level, would have to consider the possibility that their actions are being observed by their simulators and maybe rewarded or punished.
Based on
What?
morality.
Plausibly, yes. Moral criteria seem like a possible basis. So an afterlife being rewarded or punished or maybe just rebooted into another simulation based on your behavior suddenly becomes a non-zero possibility.
So it creates this kind of universal pressure to be good, because big simulator might be watching.
He calls it a potential universal ethical imperative or a virtuous circle. It could be in everyone's rational self-interest across all simulation levels to behave ethically.
Wow, that's unexpected. The paper also briefly mentions weird ideas like me simulations, just simulating one person.
Yeah, or simulations with sort of shadow people who aren't fully conscious, or simulations where people have shortened lives or false memories implanted. Which he notes could be a really far-fetched, maybe slightly disturbing solution to the problem of evil, if you're not the one currently suffering, I guess.
It's more of a conceptual aside, really.
Right.
But the main point, and this is crucial,
Yes.
Bostrom emphasizes that even if we are living in a simulation, the practical implications for our everyday lives are probably not that radical.
Well, surely. How so? It sounds reality-shattering.
Because our best guide to how our simulated world works, how our creators likely set it up, is still just observing it,
Yeah.
doing science, studying the patterns in the universe we see.
So the laws of physics still work tomorrow, gravity still holds, I still need to eat.
Pretty much. The simulation hypothesis shouldn't make us go crazy, as he puts it, or stop us from planning for the future or living meaningful lives within this reality, whatever its ultimate nature. The universe still seems to behave in predictable ways, simulated or not. Okay, so let's try to wrap this up. To bring it all back, based on Nick Bostrom's pretty rigorous argument, one of these three big propositions must be true. 1, humanity almost certainly goes extinct before reaching a post-human stage.
Or 2, post-human civilizations, if they exist, are almost certainly not interested in running ancestor simulations like us.
Or 3, we are almost certainly living in a computer simulation right now.
And in what Bostrom calls our current dark forest of ignorance, where we don't really have strong evidence pointing definitively to one over the others, he suggests it's probably sensible to kind of spread our belief roughly evenly among these three possibilities. For now, anyway.
Right. Just keep an open mind about all three. And that final, really powerful takeaway statement from the paper, the one that really sticks with you is, unless we are now living in a simulation, our descendants will almost certainly never run an ancestor simulation.
It really puts our potential future, or lack thereof, into sharp focus, doesn't it?
It absolutely does. So, for you listening, which of these possibilities actually gives you the most hope for humanity's future? Is it better to think we're doomed? Or that we become fundamentally disinterested? Or that we're living in the Matrix?
And maybe ask yourself what, if anything, would actually change about how you live your life day to day if you truly deeply believed you were in a simulation.
Definitely something to ponder. Until our next deep dive.